Now that all of your appetites are sufficiently wet, you've been waiting, it's this nice cliffhanger. Thank you for coming. We might speak slightly quickly, given the time. Lots of interest in this topic, service mesh. Who's doing this? Oh. That warms my heart. That's fantastic. Excellent. Who? Well, so my name's Lee. The co-presenter is Girish. We were here at KubeCon last year, giving a workshop on service mesh. Who was at that workshop? Anyone? It was very good. Okay. You did not learn your lesson earlier. You were going to suffer more today. We gave a lot of workshops. We gave them at DockerCon, at Velocity, at KubeCon. Surprisingly, this conference actually asked us back, so they didn't learn their lesson. We got a lot of questions. Some of those questions were trying to grok the various service meshes that are available, that are out there. But a fair number of questions around related technologies, which makes a lot of sense to me. As I go to learn a new concept, a lot of times it's very helpful to me when someone compares it to something I already understand. I've got a common kind of mental framework for it. In this case, API gateways, client libraries, they say that they do similar things, and they do some similar things. This is not that talk. Point of this is to say there is an emerging landscape. There are a number of service meshes available. You've got choice, which is excellent. It also brings with it some challenges as you go to try to figure out what choice to make and what to adopt. Those challenges include the two most commonly asked questions from our workshops. Each of the questions started with, were pretty similar. We were done at the workshop. People were absolutely blown away, mostly by the presentation and the corny jokes that I had had. But they also said, for the most part, hey, we see the value of this service mesh. We want to try it out. We're ready to adopt. Which one should we use? How should we get started? How much is this going to cost us? What's the performance overhead here? Very rarely, if ever, do you get something for free. We didn't necessarily have fantastic answers on behalf of the projects that we were speaking about, on behalf of those meshes. Some of these service meshes are easier to install than others. Some of them are perhaps more performant than others. Answering that second question is a nightmare, actually. Really hard to do comparatively in an actual apples-to-apples way. I think maybe convinced at this point that that's an actual exact same comparison is probably not feasible. But we can get close enough, or you might be able to get comfortable and close enough that you understand what that cost is, and you weigh it against the value that you derive from having deployed a service mesh. We're going to talk about a tool that will help us in this regard. Before we talk about that, I want to acknowledge that not only has the landscape been evolving, but service meshes themselves have been. I suspect some of us, it wouldn't take maybe just one row of folks here in the audience to disagree about the definition of a service mesh, potentially, and sort of what makes one. Let's see if we can disagree together right now. You can, if that happens, please ignore my Twitter handle. Go talk somewhere else. So there's two concepts here. I expect most of you that are here have probably already grokked service meshes. This isn't that talk. So you're probably familiar with the concept of a data plane, particularly if folks have any kind of a networking background. So please, yes, solidarity. Very good. OK. So some of these terms, and even if you don't have a networking background, these terms are kind of familiar to you anyway, as you've no doubt heard about control planes quite a bit. A lot of times those are talked about in a network-centric discussion, but certainly that concept applies to, well, to Kubernetes as an example. So I won't explain these because I expect that folks pretty much know what those are. In the annals of computer science, when folks are studying TCP/IP and becoming a network engineer, typically you also talk about a management plane. And I suspect there's a need here for a management plane as people go to earnestly adopt service meshes. Important to look at the architectures for a brief moment. Really, the point here isn't necessarily to comprehend all of the moving parts. The point here is to understand that just like container orchestrators were made differently, performed differently, and did slightly different functionality, so too do service meshes. Right? Here's another prominent service mesh. A lot of similarities, some differences. There are more of these nerd charts at a resource I'll point you to later. These are really fun to spend time on and just try to tweak. I'm going to skip some other ones, but there's probably, maybe by my count, about 10, a little over 10 service meshes. You've no doubt heard of the two that you just saw. This is amazing. I can get this far into the talk and not actually say the name of the service mesh, so I'm surprised. So not only are the architectures different, not only do the features and functions differ, but the deployment models can differ as well. I don't know if you caught some snark on those last couple of slides. Maybe it's good that since my Twitter handle is on the pages that I didn't get snarky about my definition of a service mesh. Come ask me. I'll be happy to tell you. It was on the slides in case you saw it. We're not going to actually discuss the advantages and disadvantages of different deployment models. Rather highlight just a couple to say different service meshes have a number of different options for how they get deployed. This particular diagram is probably an easy starting point. Starting with an ingress gateway is something of a gateway to service meshes. It's a good place to start. It's a good place to modernize your existing monoliths. So proxy per node, which is more or less an agent, a daemon set, if you will, an agent per node. Advantages, disadvantages. Small print here. The slides are available later. The point of what we're going to discuss today isn't so much the particulars of each of these, rather to point you to resources that can explain them better. We want to talk about, get back to what does it cost to run a service mesh? Which one do I use and how do I get started? We want to get back to those questions. Free book. Hit the URL. I think you've got to give up your email address to get it, but it's free. So about 4 months ago, I decided that we really were tired of not having answers to those questions. And so we started an open source project. Called it Meshery. Maybe because I couldn't think of anything more clever. A lot of folks think I'm saying mashery, I think, but we'll get that corrected. It's a multi-mesh management plane. It's a multi-mesh performance benchmark and playground. It's also a Google Summer of Code project, which is kind of neat. We've got some bright young individuals helping us on this project. We also have a couple of PhD students at the University of Austin, Texas, which is where I'm from, is Austin, Texas. If you guys, if that wasn't obvious from my accent earlier. Good. Good. Who's done a Google Summer of Code project? I'm curious, because I know this has been around a long time. People have touched up against this? Yes, sir. OK. I'm feeling special. Meshery's architecture, Meshery as a management plane, as a piece of software, is really rather simple. We're going to show it to you today and hopefully demonstrate answers to those two questions that we've asked before. Rather simple, Meshery does require that you have a Kubernetes cluster. If you do, you'll point Meshery at it and deploy adapters, service mesh specific adapters. Right now, this project, about 4 months old, it has 3 adapters for Istio, Linkerd, and Console. 2 others are being contributed by other projects, the Network Service Mesh, which is a CNCF sandbox project, as well as Octarine, which is another security-centric service mesh. Those adapters are forthcoming. While they're individually contributed, interestingly, if you were, was it Monday? Or was it yesterday? Yesterday, thank you. Very good. If you watched Gabe from Microsoft up on stage, he talked about SMI, the Service Mesh Interface. I imagine many of us are still puzzling over what that means to us, or what that is and what it means to us. True to what I'd said before about, at least for me, learning by relating to something I already know, or at least I'm already familiar with. If you think about CNI, the Container Network Interface, CSI, the Container Storage Interface, CRI, the Container Runtime Interface, SMI, unfortunately it's not a C, I'll try to fix that, Service Mesh Interface. Even without explaining what it is, my hope is that sort of settles in a little bit. Very young specification. Does have partnership and support from a number of the players in the ecosystem, including this open source tool, Meshery, which is compatible with this very young spec. This spec is, well, I already said it, young. On this, it's probably time to invite my co-presenter up to begin our demos, because what we're going to do after this demo is we're going to show some results. So we've been working with the community and a couple of PhD students, like I'd said, to try to be academic about studying all of the variables and doing some performance engineering over these service meshes. There's been a number of people who have put out. Yep, if you, I'm just chewing the fat until you're up here to present. There's a number of recent reports. Actually, one that was just done, a study commissioned by Linkerd to a group of bright folks at Kinvolk who's seen this. The thing I'm talking about, it just happened this last weekend. Right in time for KubeCon, OK? Anyway, so the net of it is there are a number of people putting out or performing tests, putting out these tests. Part of it's really hard to get an apples-to-apples comparison. Who does performance engineering? Who's in this? OK, yeah, we'll commiserate later, because it's hard. There's so many variables to control, right? So what am I talking about when I say that? If you want to test, if you want to compare how does one service mesh perform with the next, you probably need to run it in a very similarly resourced environment. Similar traffic. It needs to be inside of a vacuum. It needs to be probably the same app, same rate, same sustained rate. Different, there are many different variables to account for, and different meshes are going to perform differently. The thing is most of the meshes are fairly configurable in terms of what you want them to do. Do you want them to enforce security? Do you want them to reject things? Do you want them to gather a ton of telemetry and send it your way? You just kind of open up the wallet wider, I think. You pay for each of those things.
Hey guys, my name is Girish. When he introduced, I wasn't on the stage. I was taking a seat with you guys. So I'm going to actually showcase Meshry. And of course, it's something like risky to actually do in this kind of an environment because I have a lot of network issues. Obviously, it's not something new that you guys don't know about. So hopefully, I've tried my best to pray as much as I can to the demo gods, and I've come here, so I'm going to give it a try. So if something goes wrong, it's usually just normal, specific to my environment. Like usually it's not a persistent problem. So the first thing we did with Meshry is, I think he actually told you, the route to Meshry. It's okay. As to what Meshry is attempting to address or where it's going eventually is kind of the initial thing. So today, it's been about 2 to 3 months. We started kind of doing some development on Meshry, and we've been making some progress. Like he mentioned, we have 3 functional adapters. Again, the extent to which they are functional is totally the community contributions. So in order to make people's life easier, if you just want to try Meshry, what we have done is we have actually put together a CLI, a simple CLI, which I'm going to actually showcase as a starting point, which actually helps you get started with Meshry. But before I actually start typing more, can you guys see my screen well? No, okay. Good. Okay. Thank you. How about now? Is that better? Okay, I presume everybody can see it. So the name of the CLI, obviously, we have called it Meshry. And if you actually just hit enter, it'll actually give you a decent help. So there is a start-stop update for updating the images, logs for getting the logs from all the containers, and a status to actually report on the status, and a cleanup, which actually, if, for example, if there are some network issues, when downloading the configuration, you can actually run cleanup and then start. It'll again do a fresh start. But in my case, I already have the configurations ready. Now, this is a very simple script as of today. We are working on improving it with more features. But like I said, it's a very simple script, which is just wrapped around Docker Compose. So if I actually run start, you'll actually see how Meshry actually starts. I'll just go back to my screen for a second, and you can see those are all the services that are running in Meshry right now. So you have a question? Okay, gotcha. So you can see, Lee already introduced the architecture of Meshry. So there is a Meshry app, and of course, we have all the adapters. So right now, as part of this deployment, you can see the Meshry console, Meshry Linkerd, Meshry Istio. So those are the adapters that are actually being deployed by default. If when you guys run Meshry, and immediately it actually opens the browser, and you will be taken into the Meshry app. Now, Meshry's app itself, so as of today, it's actually split into 3 parts. Mainly, first one is a performance section, because that's one of the main questions Meshry is trying to help answer. The other one is a playground component, which is where it actually will let you play with the service meshes. And the third one is actually the results section. So we also give you the capability to actually persist the results and compare them. So which I'll walk you guys in the next minute. So as a first step, I'm now connected to Meshry. The first step, would be to actually configure the playground components. So obviously, as of today, since most of the meshes that is publicly known work well with Kubernetes, we have started to base it off of Kubernetes. Eventually, we could move away from it. So the first thing is, I pick a configuration file. It can be a kubeconfig file, but it has to be a valid kubeconfig file. We have some validations in place, but obviously, so once a valid kubeconfig file is presented, you hit submit. It's validated, and once it's accepted, you will actually see the indication that the kubeconfig is accepted. The next thing is the adapters. Also to note is that there is an asterisk right next to the first 2 sections, just the Kubernetes and the adapters. Grafana. So we also have an integration with Grafana, which I'll briefly showcase. But the first 2 are mandatory if you want to actually make it talk to a service mesh. The Grafana component is optional. And you can see here the existing adapters will already be listed. So, for example, you can actually connect to Istio, and it'll automatically be shown.
You want me to speak to it while you do it?
Sounds good. Sure. Yeah.
Keep going. Okay. Good deal. Hopefully that's very obvious what just happened. That doesn't need speaking to.
So you can see
it doesn't need speaking. Yep. All right. So let me, since you're not Mike, I'll speak to this just to get both of his hands on the keyboard because we want to show you some results and we got late started. Here you can see that each of the adapters have some common functionality. Hopefully as we move forward with Service Mesh Interface, that new specification, that will help with that common functionality. Right now, because not every service mesh is made the same, you will find different capabilities in each adapter. This is also in part based on the service meshes that have contributed those adapters. They've written more things versus the next one. And so with that, one of the things that people are able to do is apply a custom configuration. So if you have a YAML configuration that you'd like to push to your mesh, you could do that through the tool. Once you've gone through this configuration, you've connected up your adapters, you can the Meshery will facilitate deploying sample apps. Each of the service meshes come with their own sample app to show off what a mesh does and help you understand it. Meshery helps you cross-deploy those sample apps across different meshes so that you can have kind of an apples-to-apples comparison as you go to run performance tests.
So this is the brief introduction to the Grafana integration. So I'm not sure if you were watching. I just gave the URL to a Grafana, it immediately connects to it, and it also fetches the board information. You can actually search. You can pick and choose the panels from a board, and once you click Add, you can actually see the Grafana charts integrated at the bottom. To just validate, you can actually expand and see the charts. And of course, we've tried to give the same behavior, with the Grafana filters. Now, once you have configured Grafana, then you go to the load testing page. So here, you can actually perform the load test. Now, given the time, I'm not going to show it, but here you can actually pick a service mesh, just to it's kind of a label right now. We're not having some intelligence, but so eventually we will. So this page, obviously gives you the capability to run a load test against the app, and the latency and the throughput will be shown in the chart here. And below is the Grafana connection. So essentially what we're trying to do is provide a single pane of glass where you can actually see the client-side metrics and the server-side metrics. And of course, so the last but not the least is the result section. So every time, a load test is run, the results are persisted, and you can always come back and see your results. For example, so that was one run, and you can see another run side by side, or you can actually, use some comparison features we have in place, which is again, all based off of some existing tools, to actually see the, the comparison between, different results. So that's Meshery.
Yeah, very good. Let's get some other results up. So Meshery is an open source tool. It's a community contributed thing. There is a slide in there that does thank our contributors. That's fantastic. We've come out with some initial results. There's yet to be an academic paper published, and that's really what needs to happen here. There's a lot of details that folks need to grok and take into context. In this particular environment, the results that are being shown are from a single node Kubernetes cluster running Ubuntu, running 24 gigs of RAM, an 8-core single CPU system. There's a bunch of specifications and details that aren't in these slides that will be shared. I think the thing to take away here is as you understand that different service meshes, their sidecar, the service proxy that they use, as you go to understand that different meshes' sidecars take up more memory maybe than the next one does, please also understand that they're performing different functionality. Some of them are gathering a lot of telemetry. Some of them are just facilitating an MTLS connection. Right? So there's a lot more context to this. So please don't walk away today saying, well, looks like on the relative scale, that one's junk versus the other one. And that's not the case. These simple slides don't do that justice. They are eye-catching and sure do make for a great tweet. Be careful as you do that, please. The full report and spec and kind of the publishing of that will happen. This is analyzing the sidecar again, the data plane, saying how much CPU is burned by that sidecar in these environments by these different. So this is the identical environment. This is the same application. This is the same request rate, the same load being placed on each of these. The caveat, probably the biggest caveat, like I'd said before, comes in where they're not performing the same functions. So recognize that. That was the data plane. Let's take a look at the control plane. Well, I hesitate to do this. I'm almost compelled to. One of the things that needs to happen here, I think that will be insightful for folks is, again, boy, this is the third time I'm going to make this analogy, is that I learn by comparing to things that I already understand. If I think I understand container orchestrators pretty well, Nomad, Mesos Marathon, Kubernetes, Swarm, I've laid them out on a spectrum before, saying some are easier to stand up than the others. Some are more powerful than the others. I think a spectrum like that and something of a quick comparison like that may help folks. We didn't put it in here. I'm not going to say what my perspective is there just yet. So hopefully that was memory. Yep, this is CPU. Again, context behind this needs to be shared. Given the time, there are other results that we've begun to publish. What I will say is that, yes, we've got, we might be at time. What I will say is thank you to our contributors. A number of these are the service mesh projects themselves. Some of these are just folks who need an outlet to express their passion, so thank you for that. The last thing I'll say is if you're interested in the results when they are ready, or if you're interested in just learning more about meshy things, Layer5.io is a service mesh community. It's intended to be a repository of information about meshy things. You'll also find some other free workshops that we've given, the workshops that we've given at these past DockerCon, KubeCons, Velocities. They're there, the free ebook. There's the service mesh landscape, and then Meshery itself. Give it a shot. Arguably, I think arguably it's maybe the easiest way to try out a service mesh. While that's arguable, what isn't arguable is it is, will soon be the tool that lets you try out the most service meshes, I guess. Anyway, not important, but please come see us if you're interested in more of the details. Do subscribe. The students that are working on this would love your feedback. So, thank you.